Have you ever wondered how a computer remembers a specific number to use it later? Imagine the computer's memory as a vast, empty warehouse. A computer doesn't intuitively understand a number the way we do. To keep track of a value, we have to provide specific, clearly labeled digital boxes to put that number inside. In programming, the system we use to categorize these numbers is called numeric data types. This diagram shows how numeric data follows two different paths, depending on the exact kind of number you want to store. Learning how these categories work is the first step toward giving the computer instructions it can actually follow. Let's look at the first category. This path is used exclusively for numbers that are whole and complete. In this diagram, we see these solid shapes representing integers. An integer is a number with no fractions or decimals, like 10, 50, or 100. But sometimes you need more than just whole numbers. You might need to track a price or a measurement that requires a decimal. Looking at this visual, we see the representation of floats. A float is a number that includes a decimal point, such as 36.5 or 99.99. By picking the right category, you tell the computer exactly how much space it needs to set aside for that specific number. Now that we have our numbers sorted, we need to learn the grammar of how to label and store them. In Python, this grammar is called syntax. This code shows how to create a label for a person's age. Notice the arrow moving right to left. Python strictly requires the label, age, on the left side of the equal sign. Reversing this order stops your code, a common beginner mistake. This happens because a computer cannot put a storage box inside a raw number. The number 20 is just a value. It can't act as a container for other information. Following this left-to-right grammar ensures the computer can find and use your stored data whenever you ask for it. Let's see how this works in a real-world scenario. We'll use Python to calculate a total in a digital shopping cart. We use an integer to represent a product's base price, assigning 1,000 to the label product price. Next, we add a float, assigning 200.50 to discount. Finally, we subtract the discount. The total automatically updates. These simple rules for labels and numbers are what make it possible for a shopping cart to handle calculations for customers every day. Before you start writing code, there is one warning you should keep in mind. A tiny change in how you type a number can stop your math from working entirely. This diagram shows the issue. Placing quotation marks around a number when setting up your label. Those quotation marks tell the computer to treat the number as plain text rather than a mathematical value. Because the computer now sees this as text, it can no longer add, subtract, or perform any math with that specific information. Getting these labels and types right now makes it much easier to build more complex programs.